Today we're going to talk about how to write numbers in scientific notation. Scientific notation is a method of writing very large or very small numbers in a more compact manner to make it easier to work with those numbers. Let's say we start with a very large number. Let's try 2,700,000,000. First step in understanding scientific notation is to understand that this number is the same as 2.7 times 1 billion. Because we have 2 whole billions and then 7/10 of a billion. So we're always looking for the closest power of 10. And by power of 10, remember that means any number that can be written as just zeros, because that's a product of tens. Then what we do is we rewrite that 1 billion as an exponent or a power of 10. So first of all, we have to figure out what exponent we need in order to bring 10 up to 1 billion. Now the nice thing about powers of 10 is we have a very simple way of figuring that out. All we have to do is count the zeros. Essentially we're counting the spaces from here all the way over to here. So if you count those spaces, you'll find that we need 9 tens to reach a billion. If you do 10 to the 9th power in your calculator, you'll get 1 billion. Of course, some of your calculators won't be able to fit a billion into their screen, and so they'll write it as 1e9. That's 1 times 10 to the 9th. That's their form of writing scientific notation. But you could check, because you can multiply 2.7 times 10 times 10. You can go through that, so you have 9 tens. And when you come out from the other end, you'll end up with 2,700,000,000 after you've done all of that product. I think I've got enough tens there. Nope, I need one more. So you see, we save space and we save time by writing it in scientific notation. This also allows us to fit large numbers on small screens, which is essential for calculators. Now I want you to notice something else. That 9 that we have right there is the same as the number of spaces from here over to here. Now our rule when scientific notation is that we can have one non-zero digit left of the decimal in order for it to be in proper scientific notation. So if you look at our proper scientific notation, this was our final product here. We have one digit left of the decimal that's not 0. That means I wouldn't want 27 times 10 to the 8th. Although that's equal, that's not in proper scientific notation because it has 2 digits to the left of the decimal, and we can only have 1. So that tells us that the decimal belongs between the 2 and the 7. Let's write another large number in scientific notation. 42,590,000. Now, when we're done, we want one non-zero digit to the left of the decimal. So we look for the digit that's farthest to the left, which is 4. That's going to be our digit that's to the left of the decimal. Everything else comes after the decimal, but we don't need to write all of the zeros. Then, since it's scientific notation, we know that we're taking out powers of 10. The question is, how many? So how many spaces do I have to move to get from 42,590,000 to 4.259? 3, 6, 7 spaces, which means I need 10 to the 7th. That's my answer in scientific notation. Let's work it in reverse. Let's start with a large number in scientific notation and write it in standard notation. Standard notation is the form that you're used to writing it in. Let's try 2.0075 times 10 to the 6. Now, if we think about what we would have had to do to write this number in scientific notation, we would have started with a big number and moved the decimal over next to that 2. So all we have to do is move it back. It moved from somewhere over here to here, and it moved a total of 6 spaces. So we want to move it 6 spaces back. Well, here's 1, 2, 3, 4 spaces. We need 2 more. And the only thing we can fill that with is zeros. So our number in standard notation will be 2007500, and if we place our commas, we'll see that we come up with 2,007,500. Now, as I said, we can use it for very large numbers, which we've been doing, or we can use it for very small numbers. Very small numbers are a little bit different. Now we know that for scientific notation, we want our decimal place to be between the 5 and the 7. But this number is not 4 times 10 to some power. It's 5.74 divided by 10 to some power. Because if we remember our decimal place, this 5 is in the tenths, hundredths, thousandths, 10,000ths, 100,000ths place. So we have 5.74 100,000ths. Now if we write that as a power of 10, that's 1 over 10 to the negative 5 power. 10 to the positive 5 power. And if we write that as a normal number, it's 10 to the negative 5 power. So that's what I'm going to use to fill in my scientific notation. But notice something again. Our decimal started here, and it moved 1, 2, 3, 4, 5 spaces. But since it made a small number bigger, we use a negative exponent. Let's do another one of those. Let's try 0.000127. So what we do is we figure out where our decimal belongs. Now since we want one digit to the left of the decimal, we look at our first non-zero digit, which is 1. And then all we have to do is determine how many spaces our decimal needs to move. 1, 2, 3, 4 spaces. And since I'm making a small number bigger, it's got to become negative 4. Now, if I had a number in standard notation like that, or in scientific notation, and I wanted to write it in standard, my method is very similar to what I do with the big numbers. I know that I've got to get to scientific notation, I had to move my decimal 4 spaces to the right. So I'm going to move it 4 spaces back to the left. So I still have that 1685, but I had to move that decimal 1 space, 2, 3, 4. That's where my decimal is going to belong. So the only thing I can put in those open spaces are zeros. So I have 0.000165. There's my number in standard notation. I'm going to give you a few of these to try on your own. I'm going to give you 2 to do 2 in standard notation to convert to scientific notation, and then 2 from scientific notation to convert to standard. So let's do 1,257,000, and let's do 0.000046. I want you to convert those to scientific notation, and I'll give you 2 in scientific notation that I want you to convert to standard. Let's do 3.25 times 10 to the 8th power, and 1.79 times 10 to the negative 6th power. So take a couple of minutes, write the top ones in scientific notation and the bottom ones in standard notation, then unpause the video and see how you did. Okay, starting with the top ones, we know that we want one non-zero digit to the left of the decimal, which has to be our first digit, 1. Then we need to see how many spaces did I move the decimal. 1, 2, 3, 4, 5, 6. So I need 1.257 times 10 to the 6th. For the second one, I need one non-zero digit to the left of the decimal, and my first digit is 4. I'm going to start with 4.6, then I need to count decimal spaces I moved. I moved it 1, 2, 3, 4, 5, 6 spaces to get it right here. So I needed 4.6 times 10 to the negative 6. Okay, down at the bottom, I need to take my 3.25 and move that decimal 8 spaces, while the 2 and the 5 are together 2 spaces. So then I need 1, 2, 3, 4, 5, 6 more. Then I can place my commas, and I see that I have 325 million. And the last one, I've got to move my decimal space, our decimal point, 6 spaces to the left. So I have my 179. That 1 was 1 space moved. Then I got 1, 2, 3, 4, 5 more spaces moved for a total of 6 spaces. So there's my answers. That's how I convert numbers to scientific notation or from scientific notation to standard. In the next lesson, we'll be working on multiplying and dividing with those scientific notation numbers and putting them in order. If you have any questions, feel free to ask. If not, you can move on to your homework.